Have you ever stared at a math equation on a chalkboard and just thought to yourself, okay, when am I ever going to use this in real life? Well, what if the answer was when you literally need to save the fabric of reality? I mean, what if abstract math wasn't just, numbers on a page, but a literal high-stakes survival tool?
Welcome to today's Explainer. I am so incredibly excited to have you here with us. Today, we're diving into the amazing journey of an 8th grader named Leo. He's the hero of the epic adventure book, Leo and the Secrets of Mathematica, the Realm of Relations. And we're going to see exactly how the Pythagorean Theorem saves worlds. We'll explore how Leo uses core math concepts, specifically that famous theorem, not to just, pass a pop quiz, but to survive deadly traps, build literal bridges of light, and save an entire world. So let's just dive right into this.
Here's our quest map for today's Explainer. We're going to cover 1. The bond breaker's threat. 2. Forging pure logic. 3. The scaling trap. 4. The Pythagorean ascent. And finally, number 5, embracing the irrational. All right, let's get going.
Section 1. The bond breaker's threat. Because, well, to understand the stakes here, we first need to understand our terrifying enemy.
In Mathematica, Leo is up against this deeply unsettling antagonist called the bond breaker. And this villain has one goal: to sever every single mathematical relationship in reality until literally everything falls apart into just disconnected floating points of light. It's pretty bleak. So to defeat an enemy that breaks connections, Leo has to form new ones. He teams up with 2 fascinating companions who see the world in completely opposite ways. First, there's Radix. She's the forge master of the right angle, totally practical, and she only trusts the physical precision of her measuring tools. Then on the other side, we have Nomad, the spirit of functions. He doesn't really care about the individual pieces. He looks at the abstract bonds and the overriding rules holding everything together. Leo's job? He's the connector. He has to fuse their contrasting philosophies to forge the ultimate mathematical toolkit. Moving on to Section 2, Forging Pure Logic. Let's take a look at how Leo handles his very first major trial at the Pythagorean peaks.
So up in these peaks, the bond breaker's corrupting energy is actually making Radix's physical measuring tools completely useless. Even her absolute favorite prized set square keeps throwing out these tiny, frustrating errors, like giving her 89.5 degrees instead of a perfect 90. So she challenges Leo to create a completely flawless right angle for her forge from scratch without using any corruptible measurements. And Leo realizes something pretty brilliant here. When physical tools fail, you have to rely on pure mathematical logic. He remembers a super fundamental concept from Euclidean geometry, the perpendicular bisector. Now, if you need a quick refresher, a perpendicular bisector is basically a line that passes exactly through the midpoint of a segment, intersecting it at a perfect 90-degree angle. Every single point on that bisector is equally distant from the 2 endpoints of the segment.
Armed with just a glowing magical compass and a straight edge, Leo goes to work. First, he marks 2 points. We'll call them A and B on a metal rod. Second, he draws an arc from point A and then another identical arc from point B so that they intersect perfectly right in the middle. And finally, he connects a straight line straight through that intersection. And boom! A completely flawless 90-degree angle just blazes into existence. He didn't measure a single thing. He built it with absolute truth.
Which brings us to Section 3, the scaling trap. With their new tools forged, our heroes step into a proving ground that's laid with a seriously deadly curse. They find themselves in the Echo Garden. And to activate a defense mechanism here, they have to create an echo, which is basically a perfectly scaled-up projection of this small triangular metal shield onto a massive energy wall. The original shield has an area of exactly 100 square units, but the defense wall, it requires an area of exactly 3,600 square units. So Leo does some incredibly quick mental math. 3,600 divided by 100 is 36, right? Confidently, he pushes the garden's scale factor lever all the way to 36. But instead of activating the shield, the projection becomes wildly unstable and violently explodes into 1,000,000 shards of light, literally throwing Leo backward. So what exactly went wrong here? Well, he forgot one crucial detail. Area grows way, way faster than side lengths.
Nomad steps in to perfectly illustrate Leo's near-fatal mistake, drawing squares right there in the dirt. He shows them a fundamental rule of geometry. The ratio of the areas of 2 similar figures is always the square of their linear scale factor. Think about it. If you double the sides, the area doesn't just double, it increases by 4. So, if you set the scale factor to 36 like Leo did, the area would actually become 1,296 times bigger. Yikes. To get an area ratio of exactly 36, Leo actually needed the square root of 36. He quickly adjusts the lever to 6, and a perfect, totally stable energy wall blazes to life.
Section 4, the Pythagorean Ascent. Having barely survived that trap, they finally arrive at the core focus of today's explainer, scaling the vertical, sheer cliffs of Mount Pythagoras.
This mountain shows absolutely no mercy, let me tell you. Every single step requires completely flawless geometric calculations. So, let's step right into the action. Leo and Radix are facing a cliff that goes straight up into the sky. Radix quickly measures the space. The cliff face is exactly 8 meters high, and the ledge they are standing on juts out exactly 6 meters from the base. To cross, they have to summon a magical ramp, which essentially acts as the hypotenuse of this giant right-angled triangle. So can you calculate the length before the ramp disappears?
Leo instantly visualizes the Pythagorean Theorem in his head. A squared plus b squared equals c squared. We know the legs are 8 and 6. Okay, so 8 squared is 64, and 6 squared is 36. Add those together, and you get exactly 100. But here's the catch. While he's calculating this, these shrieking monsters called right-angle breakers are swarming the base of the mountain, furiously chipping away at the stone, trying to destroy the perfect 90-degree angle. Because if they succeed, the theorem literally breaks and our heroes fall.
Talk about extreme pressure. Leo realizes c squared is 100. He takes the square root and just shouts the answer at the top of his lungs. 10! The ramp has to be exactly 10 meters. And instantly, this brilliant beam of light shoots upward and locks firmly right into the cliffside, letting them escape the monsters with mere seconds to spare.
But hey, the mountain isn't quite done with them yet. The stakes escalate almost instantly as they reach this massive, terrifying chasm. A glowing magical blueprint appears in the air, with a stark warning. The maximum ramp length you can summon right now is 13 meters. The cliff on the other side, it's 5 meters high. Now Leo has to calculate the horizontal width of the chasm, which is the missing leg of the triangle, just to know if their 13-meter ramp will actually reach the other side before they step out and plummet into the void.
So, we are looking at another classic Pythagorean triple here. 5 squared plus b squared equals 13 squared. That means 25 plus b squared equals 169. Subtract the 25 and you get 144. The square root of 144 is 12. Leo shouts out that the chasm is exactly 12 meters wide, and since their ramp can stretch to 13 meters, it is definitely long enough to save them. Honestly, this brilliantly illustrates how the Pythagorean theorem is so much more than just some boring classroom exercise. In Leo's world, it is a literal lifeline.
Section 5. Embracing the irrational. Radix knows the mountain is rarely kind, and now they have to leave those nice, clean integers far behind. Radix wipes the sweat from her brow and points ahead to this dark, incredibly wild expanse where all the trees twist in these unpredictable, non-repeating curves. They've survived the integers, sure, but now they are entering the irrational forest. Almost immediately, they face a gap that seems, on the surface, incredibly simple. It's a cliff that is 1 meter high and a ground distance of 1 meter long. Radix calculates the ramp. 1 squared plus 1 squared is 2, so the hypotenuse has to be the square root of 2, which is 1.414, and the decimal just keeps going forever.
That's because the square root of 2 is an irrational number. It literally never ends. It has 0 repeating pattern, and it can absolutely never be written as a simple, clean fraction. For an engineer like Radix, a person who loves precise physical measurements, an infinite number is just a massive headache. I mean, how do you physically build something that mathematically never actually resolves?
A bit later in the forest, Radix understandably gets a bit frustrated. They need a bridge with a length perfectly equal to the square root of 13. Radix decides to just carve a little shortcut into the magical seed that grows these bridges. She punches in the decimal 3.6, thinking, close enough. A rigid wooden bridge shoots out over the drop, but the moment she steps onto it, glowing math appears out of nowhere, showing that 3.6 squared is only 1296, not 13. The math just doesn't hold. The bridge violently shatters into splinters, and Radix starts to fall. Thankfully, Leo manages to save her just in time. He steps up to a brand new magical seed. And this time, instead of using a rounded decimal, he carves the exact mathematical symbol for the square root of 13. Instantly, these wild organic silver roots weave themselves together, forming a completely indestructible bridge. It's exactly as Leo realizes in that moment. You can't round infinity. In mathematics, especially in this realm, close enough is completely wrong. The truth must be absolute. So, let's take a second to recap what we've actually learned from Leo's incredible ascent today. First, when physical tools and measurements fail you, pure geometric logic remains completely flawless. Second, scaling an object is surprisingly deceptive. Remember, area scales by the square of the linear factor. Third, formulas like the Pythagorean Theorem aren't just memorization tools. They are dynamic toolkits for solving seemingly impossible problems. And finally, mathematical truth, even when it's infinite, messy, and irrational, has to be respected as absolute.
And all of this perfectly brings us back to defeating the bond breaker. This villain wanted to isolate numbers and destroy equations entirely, but Leo proved that the universe is actually built on these beautiful, unbreakable relationships. The Pythagorean theorem mathematically connects the sides of a triangle. Scale factors connect the incredibly small to the incredibly massive. Mathematical equations aren't just artificial rules we made up. They are the fundamental natural connections holding our reality together. True strength always lies in connection and never in isolation.
Well, that wraps up our journey through Mount Pythagoras and the realm of relations. I really hope this explainer showed you that mathematics isn't just about finding the right answer for a test, it's about seeing the hidden, underlying structure of the entire universe. So I'm going to leave you with this one thought to ponder today. The next time you look around a room, cross a bridge, or walk past a building, what invisible geometric relationships are holding your world together right now? Thanks so much for learning with me today, and as always, stay curious.